Containers in Azure with Rob Richardson.
The Azure DevOps Podcast is a show for developers and DevOps professionals shipping software using Microsoft technologies. Each show brings you hard-hitting interviews with industry experts, innovating better methods, and sharing success stories. Listen on to learn how to increase quality, ship quickly, and operate well. And now your host, Jeffrey Palermo.
Hello, I'm your host, Jeffrey Palermo. You can go to www.azuredevops.show and see past episodes and show notes. Our guest today is Rob Richardson. Rob is a software craftsman building web properties in ASP.NET and Node, Angular, and Vue. He's a Microsoft MVP, published author, frequent speaker at conferences, user groups, and community events, and a diligent teacher and student of high-quality software development. You can find this and other talks on his blog at robrich.org/presentations and follow him on Twitter at Rob_Rich. He's also a big contributor and leader at the AZ Give Camp, where AZ stands for Arizona. Rob, how are you, sir? Good to see you.
Doing well. Great to see you again.
Yes, sir. Yes, sir. We I think recorded a group podcast at Ignite. And for those who haven't heard that past episode, that was back in November. And you can hear Rob on that episode, as well as a couple of other MVPs that we pulled into one of the podcast booths. So, Rob, you are an expert in containers in Azure, and this, the listeners to this podcast are all .NET developers using Visual Studio and shipping software in Azure, and so that's getting a lot of talk time. What are containers ready for so far in Azure?
Oh, this is really awesome. So containers take my workload and my software and put it in this really easy to distribute package. And typically when we talk about packages, we're talking about like NuGet or NPM, that kind of package where I'm packaging up just the executable. Containers are a little bit different in that they package up the executable, but they actually package up the environment around it as well. And so it's kind of this really great midway point between virtual machines on one side that package up everything, but are really heavy, and just applications that I might publish to Azure Web Apps that are, just the application. The cool thing about containers is because it's grabbing the environment, I can now use it anywhere. So I could publish it on Azure, I could publish it on my local data center, I could publish it to another cloud as well. But it's a lot leaner than a virtual machine in that sense, because a virtual machine will virtualize the BIOS and the hardware. And so step one in installing a virtual machine is to install my operating system. In containers, we're not virtualizing the hardware, we're virtualizing the kernel, the operating system. And so as I'm virtualizing the kernel, then I only need the difference between the kernel that will run my container and my application. So I'm not installing Windows a second time or Linux or whatever OS I'm choosing. I'm only installing my application dependencies, which may be the .NET framework or other things like that. And then I'll install my NuGet packages, I'll install my application. And so I'll bundle up this container that now will run anywhere. And so where a virtual machine might be 3 or 50 gigs, a container might be 50 or 100 or 200 megs. Mm-hmm. And that's a lot easier to start to move around my data center.
So you've done so much software development, and now I want to dig in deeper into containers, but how did you come to go deep in containers, which could be seen as an ops topic, but how did you come to that, and what significant things have happened in your career that landed you in this focus?
Most definitely. I started with building ASP.NET websites in 2002. And so at that point, we're doing web forms, and we're trying to get the hang of this HTML thing. And JavaScript was this brand new shiny thing, and jQuery got really shiny a bit after that. what I noticed was in time, I needed to deploy my website somewhere.
Mm-hmm.
And so I would reach out to, hand it off to the ops team or whatever. As I started getting closer to that, a bunch of us developers didn't know how to deploy. So I got good at Windows and Linux server administration so that I could deploy my content. In time, that turned into, well, let's build DevOps pipelines. They were formerly called CI/CD pipelines. So I got good at building build servers and building unit tests. And so this is a natural evolution. This is the way we deploy content now, is we'll deploy it into a container and we'll publish those containers into like Azure Kubernetes service or something like that. It's this natural evolution of how I get my content into place. As a software developer, as a software publisher, I need a place to run my stuff. And Docker is the natural way to do that.
Okay. So do you think of it more as a dev concept or an ops concept?
What's really elegant about containers is it really is both. And it's this really elegant, crisp delineation between the two. When I publish my content into a container as a developer, I can kind of look at that container as a machine. I can build my snowflake inside this machine, inside this container. I can, decorate the curtains just so, and I can put the chairs and the tables in places, and I can put my configuration file in exactly that random directory where I need it, and I can transform my web config just so. And then I close the doors on that container, and that container then is much like a shipping container in the shipping industry, where I have a crane that just hooks into that container in those standard 4 places on the corners and grabs that and stacks it in the ship. As an ops person, I can think of that container not as a machine, but as a process, because everything else running on my operating system is a process. So I launch this process. I can constrain that process. I can give it access to certain ports coming in. I can give it access to a certain amount of CPU and memory. And as an ops person, then I know how to run these standard things. I know how to stack my containers in my ship. And so from a dev perspective, we think of it as a machine. From an ops perspective, we think of it as a process. And that delineation of roles becomes really effective in being able to make this system work. One of the beautiful things there is both dev and operations are using the same tool. And that is phenomenally cool. Traditionally, what we have is we have this 7-page Word document that explains the deployment steps, of which, step 5 is season to taste. It's about, modify the config files to fit. And it's like, well, as a new person to the team, I don't know what that means.
Yeah.
And then further down the list, there's, step 13, which I can't do because I don't have permissions to do. So I go try and pester the guy. No longer do we have this big Word document of deployment steps. Instead, developers publish these containers. Operations takes these containers and stacks them in place in their orchestration cluster. And so at that point, that clear delineation, both sides using the same tools, allows for really, really smooth deployment and really clear separation of duties.
So there's probably quite a few people listening to this podcast that have existing .NET Framework applications, and they're thinking, okay, I'm hearing a lot about containers, and I know Azure has a few ways that it can run and support containers, but they're just struggling to figure out, okay, what to do next. So what are their options, and what things would push them to those options?
Good call. And one of the wonderful things about Azure is that Azure really tries to meet you where you are. And so however you're doing it, Azure probably has a way to do that. That's both a blessing and a curse, because as I'm trying to do it in Azure, there are lots of ways to do it in Azure, because any different way I would want to do it, it's available there. It's really cool because I can run a single container, either a Linux or a Windows container, in Azure Web Apps, much like I would just publish my ASP.NET application to Web Apps. But now, instead of just running as a process inside of a hosted IIS, a managed IIS, it's actually running as a container. So I can do that. All the way over to the other side, I could just prop up a virtual machine and install Docker or Kubernetes onto the virtual machine or machines and start to run containers there. AKS is another mechanism, Azure Kubernetes service, that allows us to have kind of a managed cluster of machines to be able to run containers. And there's also ACI, Azure Container Instance, which is just an API for being able to run containers inside of this, for lack of a better term, elastic infinite pool of container runtime. And so I have kind of these four places. I can prop up a virtual machine, Azure Kubernetes service, AKS, ACI, and Azure Web Apps. I'm probably not going to use all of them. I'm probably going to pick the one that makes most sense to me. And so of the two, probably the easiest to get started with is Azure Web Apps, just publishing a container. Probably in time, once you have a suite of microservices, maybe more than 3 or 5, you're going to want to flip from Azure Web Apps as containers probably into AKS, Azure Kubernetes Service. Azure Kubernetes Service as an orchestration engine then gives me a lot more power of making containers communicate with each other and automatically scaling containers to multiple instances based on factors such as CPU or request load, and ultimately containing and controlling that mechanism of how the containers talk to each other.
Okay, so that's some good concrete guidance. So there's a lot of talk about .NET Core and going to Linux containers, but then all these .NET Framework applications that are out there that, well, because you're tied to .NET Framework, you're tied to Windows. And so what should the developers consider for those applications?
Good call. If I have a .NET Framework application, I'm really bound to Windows resources, and in particular to Windows Server. Windows Server Core. I can't move to Nano Server because .NET Framework doesn't install on Nano Server. Inside Windows Server Core, I may choose to publish on a virtual machine because that's what I'm used to. That's what I've always done.
Yeah.
Or I could flip over to Windows containers, where I can publish that content into a container and run that container either on Azure Service Fabric or another mechanism like that. Azure Web Apps work great there as well. As a Windows container, it's going to be a little bit bulkier. And this is just kind of the nature of Windows being Windows. It really wasn't built with containers in mind. And Microsoft has done a phenomenal job in getting that Windows content into the container space and building the container content into Windows Server. But it's still less mature. It's completely powerful, and I would definitely run it in production. But you may choose to avoid that complexity and flip straight over to Linux. If you're in .NET Core, then .NET Core runs cross-platform. You can run it equally on Linux, Windows, or Mac. And so because Docker kind of grew up in Linux, Linux works really well with Docker. And so I'll get a whole lot smaller images. I'll get a whole lot, therefore I'll get a whole lot denser server utilization by using Linux containers. So arguably, Microsoft got so good at containers and Windows that we all moved to Linux.
Yeah, it sounds like it. I've asked this to multiple people just because I haven't found someone yet who has the formula for Windows containers where they can say, oh, here's how you do it. Boom, 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 step 1 through 5, and it works great. And the Linux containers have been around for a while, and Azure provides support for both of them in documentation, but I just haven't had a guest so far that can really outline the story on the Windows containers. And so that's really good guidance for the listeners, because it means, hey, if you're going to go containers today, you really want to go Linux just because of all the ecosystem. Otherwise, use some of the other services, maybe PaaS services in Azure to deploy your application for .NET Framework. Would you agree or disagree with any of those points?
I agree. I would argue this as well, that Windows containers is definitely ready to go. And Microsoft has done a great job at ensuring that the Docker experience is identical between Windows and Linux containers. I'm using the same Docker command line arguments. I'm using the same Docker file content. And we haven't talked about what either of those are yet. But I'm using the exact same commands in both places. It's just that I may choose some of the things to execute to be more Linuxy things, like I'm using curl, where on Windows I'll use invoke web request. So the experience between them is identical. The 5 steps to set up on Windows and Linux is identical. But the reason that I would probably avoid containers on a Windows framework application is just because I have enough legacy dependencies, enough awkward bad code in the closet things that I'm struggling with those more so than I'm struggling with containers. There's things like licensing, or it presumes a host name, or those types of concerns that I struggle with when I start to move from my favorite server that is my pet to kind of a more containerized, more cattle-like environment where the server name is less important. Those are the things that I struggle with. The fact that I'm doing that as I move from virtual machines to containers probably has very little to do with containers and more to do with my application was architected in a time where these weren't concerns that we worried about.
Oh, that's a good point. There's so many people have put in assumptions or specifics about the environment into the actual code, and then changing the environment could be an issue.
Right, exactly.
Okay.
The thing that I stumble over is session state. If I presume that I'm coming back to the exact same server, therefore my session state is populated, the moment I go from one server to 2, a lot of things fall over because I may go to the other server in my farm. Containers make that ever so much more poignant because I could go to one of 10 or 15, and I just have that slider bar to say how many containers do I want. And containers may recycle at any time. So there's no guarantee that I get back to the same ASP.NET instance that had my session in it. Now, there's ways to do sticky sessions, both in virtual machines and in containers. So there's ways around that. But it's another concern I have to worry about as I move my legacy app into this modern infrastructure.
Okay. So now we're on to Linux containers for the broad guidance then for folks, and that means .NET Core, which .NET Framework, a lot of applications upgrade to .NET Core surprisingly easy if you don't have dependencies. But let's just take it one step at a time. So if someone wants to create a container that packages up their application, say it has a web application, an offline job, and a SQL Server database, what are the critical steps to do that?
That's a great example because that really kind of is the classic application. I'll have a Windows service, and I'll have a website, and I'll have a data store, and the two of them will probably communicate through that data store. So let's take the website first because that's kind of the more traditional containerized thing. I'll start out with a Docker file. And this Docker file is configuration as code. It is the steps involved to take my source code or my built content and publish it inside of a container. And so I could build in Visual Studio and then publish the built content from Visual Studio into the container. Or I could take the other approach of getting the container to build the content as well. And as we're moving from, works on my machine towards a DevOps pipeline, then that build inside the container is kind of that natural evolution of that. So in my Docker file, I'll specify the steps that I do to build and publish this application. So the really cool thing in .NET Core is it's .NET restore, .NET build, .NET publish. And so if I have my unit test, the step in between those will be .NET test. Yeah. And so I'll prefix each of those lines with a run command inside my Docker file. I'll say run .NET restore. And that then is that command that does that NuGet restore for my packages. And then I'll have another one, run .NET build, and I'll say -C release so that it'll build in release mode. And so each of those commands will specify the steps to get from the base container to my built output. Well, what is that base container? Well, I'll go to hub.docker.com and I'll go search for probably Microsoft/.NET, and I'll go find that base container that I'd like. In this case, I'll probably end up with Microsoft's base container for .NET Core of the version that I want, 2.2 or 3.0, or, we haven't figured out what the end game, it might be .NET 14. So I'll grab that base image, and then I pick one of the flavors. In this case, because I'm building the content in that container, I'll probably pick the SDK base image. So I'll say from Microsoft/.NET :2.2 SDK Alpine. And yeah, I'm coding in words and that's hard.
Sure.
But that then specifies the base image. And there are things installed in that base image. I pulled that down from Docker Hub to allow me to build these .NET Core apps. And so it has the .NET Core SDK and runtime installed in it. And so now I don't have to worry about in my image installing those pieces.
Okay.
So I start out with that from line from my base image. I'll have all my run lines that do all my build steps. And then at the very bottom, I'll have a CMD line, a command that I use to run as I start up my container. And so that'll be something like .NET mysite.dll. And there's a few more things in place as well. But those are kind of the main commands. I'll also specify a workdir that says, where should I put all this content? I'll probably put it in /app or something like that. I'll have expose lines that say, here are the ports that I want to allow into my container. And so I'll craft out this Docker file that will then specify all the steps that goes into building my image. The really cool thing is in both Visual Studio 2017, if I've installed the Docker Tools plugin, or in 2019, I believe it's installed by default if I've checked the .NET Core and ASP.NET workloads, is if I right-click on my website, web application, and go to the Add menu, I have an Add Docker Support menu option. So I click Add Docker Support, and it actually builds the Docker file for me. So I like to craft my Docker files in the same way that I'll craft all parts of my application. But if you want to push the easy button, just right-click on your website, go to Add, and say Add Docker Support, and it will build out that Docker file for you. That Docker file then becomes the instructions of how I get my application into an image, which is wonderful. We haven't talked about the terms image and container yet, and so let's disambiguate them. Using an analogy, I have my source code class, my .cs file, and I will build that into a DLL, and then I will run that DLL on a website. So there's kind of those three steps. Similarly, there's the Docker file, there's the image, which is that built content, and then there's a container, which is a runtime instance of that. And so we've been using image and container kind of interchangeably so far, and I'm going to stop doing that. But I take my Docker file and I will say Docker build to get that image. And I may choose to publish that image on a registry like Azure Container Registry or to Docker Hub. And then I will say Docker run to take that image and turn it into a container that accepts inbound traffic in production.
The Azure DevOps podcast is sponsored by ClearMeasure, a software engineering firm and Microsoft Gold partner, empowering development teams to be their best. ClearMeasure equips developers with the DevOps tools, methods, and automation necessary to focus on building their applications, rather than wrestling with builds, deployments, or environments. Click clear-measure.com to see whether a DevOps implementation is for you.
Okay, so it sounds like the continuous integration process starts with the container because you do the .NET restore, the .NET build test, and then publish. You're doing those inside the container instead of just on a regular VM and then at the end of the build creating a container. Am I right about that?
Exactly.
Okay.
The most durable, the most build identical in every way type of process is to build inside that image.
Okay, so if the build succeeds, then you say, okay, this container is good. This container is configured well. It has an application that has passed all of the stuff in my continuous integration process. And now let me promote the container to various environments along the way to production. Is that right?
Yeah, I'll build this image, and this image will be indifferent of any environment. And then I will run this image as a container everywhere where I want to run it. So if I want to run it on my local machine, then I'll do a Docker run command. If I want to run it inside of my dev test environment, then I'll hand it to Kubernetes and I'll say, hey, can you run this? If I want to run it in production, I'll run the same thing. So the whole works on my machine is kind of gone because we're running the exact same everything in each place. I'm not, rebuilding it to promote it to the next environment. I'm not changing it in interesting ways. If it works on my machine, it will work identically on your machine. It will work identically in production.
Yeah.
There are differences there because there's configuration. It's like, well, my production database is in a different place than my local database. And those are things that you can inject in as you start the container as environment variables.
Well, another issue is how many application components should go in a single container. For instance, the website, the offline job, and the SQL database. If you're doing a .NET build, are you intentionally doing it on only a few projects, or are you doing it at the solution level, which might also contain that offline job?
That's actually a great question. One of the major tenets of Docker is that when you're running that container, there's only one process that's running. And that isn't a technical limitation. Technically, I could run many processes, but the Docker runtime will monitor that one process. And if that process becomes unhealthy in ways that I can define for it, or if the process stops, then Docker can take steps to notice that that container is unhealthy, abort it, and spin up a new container. How easy is it to find a VM in your environment and notice that that VM isn't healthy and kill it off and install a new one? That's days.
Right.
But in the Docker environment, I notice that that process is unhealthy. I kill off that container. I start a new container and my system is healthy again. That process of monitoring Docker processes, killing off dead containers, starting up new containers, that can happen automatically. I get an email in the morning saying, oh, by the way, guess what happened last night? Because Docker is monitoring that one process, that's kind of that rule of thumb. I want one process per container. I can also use that as a point of scale. I want to scale my website differently than my service. And that's another reason for one process per container. So in our example of a website, a service, and a database, I'm going to have 3 different containers. I'll have my website container, I'll have my service container, and in that third process, I could put SQL Server in a container, but in production, I probably want to use Azure SQL Database. I want to use a database as a service, whether that's Postgres or Redis or whatever data store I have. I want to use that as a service so that I can take advantage of their production uptime guarantees and their automatic backup and their point-in-time restore. I don't want to have to worry about that. Let me not put my data store in a container. I'll put that somewhere else. So then I have 2 containers. I have my website container and I have my service container. And those 2 containers are separate.
Okay, so if you take those 3 components and package them separately, but then you choose Azure SQL for platform as a service database instead of container, why wouldn't you take that offline job and throw it into a web job or Azure Batch or Azure Function? And why would you keep that in a container then?
It depends on the content that I have in that job. And so if it's something that doesn't run very often, if it's, the month-end report or something that's really bursty, like I'm running a conference and I'm going to sell tickets, and so today's the day, then that back-end service is going to get hammered, then yeah, that's probably more appropriate for Azure Functions. If I have something that kicks off every so often, every night, still Azure Functions, maybe Azure Web Jobs might be a good place for that. If I have something that's running consistently, like resizing my profile photo or calculating customer balances or those kinds of normal operations that happen all the time, then putting that in a container probably makes the most sense because it's continually running. So this kind of speaks to, as I start to tease apart the portions of my application into smaller microservices, some of those may make more sense, less as containers and more as Azure functions. And some of them may make more sense as containers because they have enough dependencies or configuration files, or the licensing terms of this particular product requires it to be just so. Ultimately, how you choose to deploy it is probably more a function of what it's doing and less a function of, the technology limitations of either Docker or Azure.
Okay, let's talk about pricing. And I don't know how much you have off the top of your head on pricing, but if you just have this application, and we'll have to discard the cases where you have super high scale, because percentage wise, most developers don't have super high scale applications. They have, moderate, and sometimes only the employees of their own companies use it. But aside from super high scale, you want your application running in Azure. How do containers differ what your monthly Azure bill might be by choosing to put it there versus the PaaS services?
Yeah, that sounds awesome. Because I'm generally running more densely than virtual machines, probably running inside of containers will be cheaper than spinning up a virtual machine and installing IIS on it. And that wasn't one of the options that we looked at. But if I've got content on virtual machines right now, and I want to cut my Azure bill, moving to containers may do that. You probably have chosen enough virtual machines now that you have virtual machines probably mostly running idle. Moving that content into containers and moving it to something like AKS, Azure Kubernetes Service, I can probably reduce the number of nodes, the number of VMs that I have handling this content. I still get that separation. I get that separation with the container sandbox, but I don't have as many virtual machines. So that cost immediately went down.
Mm-hmm. Okay.
If I only have a few things, like in our instance, maybe we only want one instance of our website and one instance of our service, then Azure Web Apps may be a cheaper option, because now I'm just publishing that content and it's handling the distribution. If I'm on a shared hosting model, then I may only have one machine dedicated to my application, one application service plan. As I move up the service plan details in Azure Web Apps, it gets generally more expensive. I've chosen larger virtual machine sizes. That benefit may go away. And so I may look at Azure Kubernetes Service as a cheaper option. What's really beautiful about Azure Functions is that on the consumption plan, I only pay for the Azure function when the function is running, when it's doing work for me. And so that arguably is the cheapest way to go, because I only pay for it as it does stuff.
Mm-hmm.
Now, if I have something that kicks off once a second, that may be less effective. Now I'm starting to...
It's almost full time.
Into Azure Web Apps or into containers. But if it's running once a month for an hour, that's fine.
Yeah. Okay. So before we go, are there any resources that our listeners should follow up on to dig in more?
I would start with a bunch of content around Azure Kubernetes Service, Google AKS, and get familiar with how it runs, because I think that's really elegant. And I would also start with kind of some Docker Hello World experiences, because Docker is such an elegant platform. And maybe even before or intermingled with that, fire up Visual Studio, install Docker for Windows, and right-click on your application and say add Docker support. Take a look at what they've built and try and debug. Part of the magic that I've seen, and this is so cool, I've chosen add Docker support, and then I've started to run my application, just debug it, and it's now debugging inside the container. Visual Studio has attached to it. It's just magic. It's just really cool. So start to see that magic, start to see the way that Docker works, and see if that jazzes you the same way it jazzes me.
Okay, so Visual Studio is connecting to the container, which is running on Windows subsystem for Linux, I'm guessing?
Actually, what's interesting is Docker can't run on Windows subsystem for Linux because it's...
Oh, it's the Docker
Linux,
VM.
But it's... Yeah. Windows subsystem for Linux is all the Linuxy bits in user mode, but it is not a Linux kernel. And that's what Docker needs to be able to reach into. So it actually, as you install Docker for Windows, it will install a Linux virtual machine. It was formerly Moby VM. It's now, I think, Docker Desktop VM. And so that Linux VM is where all of my containers are running.
Gotcha. Okay. So start up Docker, and you're actually running a VM under the covers.
Exactly.
That's why my computer got slower. No, I'm just kidding. Transparent VMs.
Yeah. All
right. Well, this is great. I think we jammed a lot of information into a short period of time. And Rob, your Twitter is Rob_Rich, and website is robrich.org. Are there any other URLs of yours that our listeners should take note of?
Those are the main ones. I'm actually teaching a Docker workshop at Indie Code coming up.
Nice.
And so it may be over by the time this podcast airs, but that workshop can get you into detail with Docker containers as well. It starts out with no knowledge of anything. The first step is for us to walk through installing Docker, but then we'll start with smaller containers and build up to a microservices thing and ultimately deploy it both to my local machine and publish it off to Azure Container Registry and host it on Azure Kubernetes Service. It's a really cool workshop. I hope you'll join us.
And that's the one on April 24th through 26th.
Yes.
Which at the time you're listening to this podcast was just last week. So how was the conference, Rob? Was it awesome?
Oh, it was so awesome. You should have been there.
And just ton of people, standing room only. I'm sorry to miss it.
Yeah.
Okay. Well, yeah, I'm gonna pull up the website now. It looks like a fantastic conference.
Yeah. Then this podcast might actually air as I'm at DockerCon teaching about Windows containers there. That would be really cool. Join us at DockerCon instead.
Absolutely. Search for DockerCon Rob Richardson, and there it is. All right.
Yeah. And if you get stuck on containers, definitely tweet me, Rob_Rich, and I'd love to jump in and let's look into your scenario and make it good. I love teaching this stuff.
Nice. All right. And I really appreciate the time, Rob. This is a great topic, and thanks for being with me.
Yeah, definitely. This has been a lot of fun. Thanks for having me on.
And until next time, keep shipping.
You've been listening to the Azure DevOps Podcast, a show for developers and DevOps professionals shipping software using Microsoft technologies. Go to www.azuredevops.show for show notes and other episodes. On behalf of your host, Jeffrey Palermo, and our sponsors, thanks for listening, and may God bless you.